Hi guys, this is S2 again. So, last time we took a look at the problem, Project Euler number 1 for the series. We used an iterative approach, which basically runs an O to the n time, which I kind of explained last time. But there's also another solution for that. So let's say we have an arithmetic series like this. 1, 2, 3, 4, up to 10. And we want to sum this. Ugh. Alright, so say this is series 1. And 4n in series. This is all just pseudocode. Sum plus equals n. Well, turns out in discrete math there is a formula that kind of does this for us. So let's say we want all the numbers divisible by 3. In this case we have numbers divisible by 1, obviously. So for the numbers 3 we have 3, 6, 9, and we want the numbers less than 10. So we can represent this as 3 plus 6 plus 9, which equals 3 times 1 plus 2 plus 3. And this summation can actually be represented by n times n plus 1. This would actually be 3 times n plus 1 divided by 2. Where I think n is the number in the set. So for our example, n would be 3. So we'd have 3 times 3 plus 1 over 2. So just to show this, we'll go 1 plus 2. Sorry for all my typing mistakes. We'll do this series where n equals 5. If you know anything about bowling, this is 15. Because you have 1 pin, 2 pins, 3 pins, 4 pins, that's 10. 10 plus 5 equals 15. So this set is 15. So that would give 5 times 5 plus 1 divided by 2. Which equals 5 times 6 divided by 2, which equals 30 divided by 2, which equals 15. So that checks out. So in our case, we want the numbers that are divisible by 3 and divisible by 5. So there's going to be an overlap there for every time we have a number that's divisible by 3 and 5. So basically the numbers 15, 30, 45, so on. So we're going to want to subtract those out of our series. So let's take our formula back to HackerRank. Let's try to do this using the arithmetic approach, which is constant time, and make sure algorithms run super fast if you can break something down into constant time. So this is the code that I couldn't get to work. Still didn't figure out why. So we're still going to need 4n in inputs. We're not going to actually need to summarize this or assign this. And we're also not going to need to run through this loop. So we can basically get rid of all this code. Can't get rid of this code because this is not our code to get rid of. This is our last submission. So let's input it. Let's get rid of these overlapping lines. Like I said, we don't need any of this. We just need our formula that we saw. N times 1 divided by 2. Where n equals dumb inputs. So I'm pretty sure to figure out that number, we just need to take our input. We're actually going to have 3 values here. So is multiple of 3 is multiple of 5, and we have our is multiple of 15. So let's actually get some functions here to do our work for us a little easier, because we're going to be doing this 3 times. So anytime you're doing the same piece of code multiple times, it's best to have a function that does it. So we will define get sum. And we don't actually need our inputs here because this is Python. So well, this will be our number, and this will be num elements. For now, we're just going to write pass. Our sum equals number times num elements times num elements plus 1. I actually wrote this wrong down here. Change that just for reference, even though we're going to get rid of it. And then apparently, if we have this does integer division, which is something that will be nice to do here, because apparently Python does some conversions behind the scenes, where it works with floats and you get rounding errors. So return our sum. So I believe to get our number of elements, we just have num elements equals n divided by actually that is 3, 5, and 15. Alright, so this actually isn't num elements. And we don't want to define that down there because we don't want to calculate it 3 different times, so it seems best to put it in here. So this is actually our input num. So num elements equals input num divided by number. So for example, if our input num is 10, number is 5, this will equal 2. That's not what we want. We want 1, because we want less than. I think it's just input number minus 1. So in the case this is 3, this would be 3, because it rounds because of integer math. Okay. So 3's equals get some get some 3 and n. 5's equals, get some 5n, 15's equals, get some 15 minus n. And by minus n I mean comma n. Change our comment so that this makes sense. Sum 4. And then our full sum equals 3's plus 5's minus our overlaps. Yep, that all makes sense, that all makes sense. And then we want to print our full sum. Invalid syntax in our define statement. I think it was actually just def. Alright, so we got our iterative answers there as we expected. And this is much faster runtime. If you remember, our failed fourth case last time was in 0.43 seconds. So if we submit this, they should all run basically the same, depending on how many number of inputs we get. But either way, it should still be a lot faster. So let's try to submit this. So here we go. Test case 0 success, test case 1 success, all successes. As you can see, our test case number 3 ran in 0.23 seconds, which is twice as fast as we ran last time, which we should expect since we're running a O1 algorithm here with our iterative, or our, not iterative, our arithmetic approach. So I'm glad we were able to get all the test cases passed and fixed. Well, actually, generally just optimize the code we had in the first time. So again, once you get a brute force solution, always think to yourself, how can you do better? Use the things that you can learn in discrete math. Discrete math? I think it's discrete math. On how to convert a series into an actual geometric arithmetic like equation here. So let me make sure that's. It's been a while since I've taken discrete math. Yeah, because there is a branch in discrete math that deal with series and cool ways that teach you how to convert them into actual equations, which I forgot, and I should probably brush up on those myself. Anyways, thanks for sticking around for the second part of this video. Take care.